All right. What do we do with something like this? Split it up. I'm going to take my fraction-y thing here, and I'm going to split it up. Absolutely every piece gets a cube root. So we're going to do our cube root of 27. We're going to do our cube root of x to the 7th. We're going to do our cube root of y to the 9th. And do one more color. We're going to do our cube root of 8. So just break it up. Cut it up into pieces. Then when we come to simplify it, just put it back in the same spot on the fraction. So my purple piece here, the cube root of 27. What is the cube root of 27? I was going to say, I think you did both numbers at the same time. You did the 27 over 8. Because you hit both of them.
9.
I was going to say 3.
3.
So our cube root of 27, you can either put it in the calculator, or you can split it up to be 3 times 3 times 3. Our one set of 3's comes up. You can put them in the calculator. How about our cube root of x to the 7th?
1.
X, yep, I can have 2 full sets.
Cube x.
Yeah, our cube root, we have 1 left over of x. How about the cube root of y to the 9th? Y cubed. Are we going to have any leftover bits?
No.
Nope. I'm going to squeeze it in front. That way I don't have to rewrite things at the end. But. And then our denominator, cube root of 8. What cube gives us 8? Two. You can also type the numerical ones. You can type them in the calculator. Totally fine.
Put it in the calculator. 3.
Wait, how just wondering, how do we do that, 8 cubed, like we did the 27?
The cube root of 8. Let's do it. So our cube root of 8. I want to break this up into things that multiply to make 8. So I could do 2 and 4. 4 breaks down into 2 and 2. So I could rewrite the cube root of 8 as the cube root of 2 times 2 times 2. My one set of 2's, that's what comes outside. I'm looking for groups of 3. What's up?
So it has to be a group of 3.
It's a group of whatever your index is.
So
The index tells you how many things. So that number in the little crook, that tells us I need a group of 3. If it was a 4th root, I would need a group of 4. If it was a 5th root, I would need a group of 5 things.
So it's not the amount of numbers there are for what the results are.
This guy is how many pieces we're looking for. This thing tells us I need a group of 3 versus a group of 4 versus a group of 5 versus a group of 10.
Right, but like since it's a group of 3, you don't know like there's 3 numbers you have to number that is being multiplied.
Correct. Correct. It's my one group of 2's. It's kind of like the socks theory, where I would have my pair of socks that we would pull out. I would still say I only have one set. It's the name of the set is whatever the letter is or the number is here in this case. So we're going to be working with the same concept as yesterday, but we're going to have a new notation for some of these things. So we're still going to be looking at this kind of stuff, but it's going to look a little bit different. Questions? Okay, it's going to look weird, and I know we don't like fractions, but I promise it's okay. Because what we're going to do is we're going to take funky looking roots like this, and we're going to put them in what's called exponential form. That what it gives us is something called a fractional index. So you don't necessarily need the paragraph, but you definitely want that picture at the bottom.
I heard something that surprised me the other day.
What's that?
Moana took in more money at the box office than we did.
There's a lot more children and a lot more grandparents that will go see that.
But it's like, didn't expect it.
Yeah, well, it's a Disney sequel. That's gonna get some big bucks.
Even though I heard it's not, my,
Lynn didn't write it.
yeah.
That's why it's different. It hits different because Lynn might also write it.
Like, my history teacher went with his kid, and he was like, "Yeah, it's the first one is like 75%."
Yeah. I'm not surprised because Lynn didn't have anything to do with Moana 2.
I am still gonna go see it.
I support it.
I would probably see it when it comes out on Disney Plus.
I've been off Instagram though.
Just full honesty, just because I don't have that much time to do movies. I need time for Wicked.
Yeah, but that's because it's Wicked.
Because it's Wicked. But I've been a Wicked fan since it came out
Social media.
in 2003. That's when it came out on Broadway.
When did For Good start becoming a tradition for pipe choirs then?
It was definitely after 2005. It may have happened when those teachers came here, because they came here after I was
Miss Dawson, probably.
probably.
This is good.
All right. So this part down here is the super duper duper important part. It's a way to write our roots of any order. We can do square roots like this. I can do cube roots like this. I can do any number of roots. What it is our index is the denominator. And if we have any exponents, that's our power on top. So we're going to switch back and forth between these two notations to start. That's just where we're going to start. So we've got our exponential form over here, and this is our radical form. We have a whole section on the homework that's about writing things in our exponential form versus our radical form. So make sure we're aware of which one is which. The exponential one has an exponent. Our radical form has the little house. And I promise there are reasons why we have this. Reasons that we do this. It makes the calculus stuff way easier if we can write it like that. Okay, so make sure we get that down because you're going to want to have that. This is one of those things that pops up fairly frequently moving forward.
Oh, I tried to watch the movie last night. We got like 20 minutes.
All right. Boop. So I've still got that form up on the top. But here's our first couple. We're just going to start by switching them back and forth. So I've got x to the power of 4/3. And we want to write this as a radical. So we have our power that goes on top and our index that goes in the radical. So on this x to the 4/3, we've got our power that's a 4 and our index that's a 3. So we can write this as our index, which is 3, goes in here. So this is a cube root of x to the power of 4. That is it in radical form. I can't.
Wait, so what is the 3 called?
Index.
Oh, yeah. So
And they labeled it n because we couldn't use I for index because I is the imaginary number, so it's n.
Yeah.
Index. Yes, dear.
So the bottom number of the fraction is always going to be the index?
Every single time. The bottom number is your index. So the second one, we're just doing the same thing but in the other direction. And that's how we're going to start. We're just going to start by switching things back and forth. I could put this as my x to the power of 2 and my index of 5. So we're going to have this as a fraction. My power goes on top. My index goes on the bottom. Okay. So on this first one up here, I want us to think for a second. I'm going to just write this off to the side. If I take 4/3 and I want to put that as a mixed number, how would we put that as a mixed number? So like where it's got the big number and then just like our remainder fraction.
1 1/3.
1 1/3, right? So 1 1/3. If I was to simplify this, like how we did in the belt work, what would we get? X cube root of an x. Yep, because we'd have an x left over, which is x to the first cube root of x. So it's a different way of simplifying. So you can simplify the fractions and it will simplify your radicals. These would be our exponents, our exponent of 4/3 and our exponent of 1 1/3. 1 1/3. You don't have to simplify like that. You can absolutely still do it the other way. But it's just another option. I wanted us to see that. We're going to practice just switching them back and forth, simplifying if we can, but also not worrying too much about it. So we're going to start by writing these in radical form. So the first one is just like the ones we've done. X to the power of 2/3, and we want to write that as a radical. So what's my index?
Index is 3.
Is the 3. And what's my power? 2. So we can write this as our index goes here in the crook. So it's my cube root of x squared. When we have something like this in a quantity, we're going to start by just taking this as it is and then simplifying. You can always do it using exponent laws, but it's been a minute since we talked about those. So on this one, that's not the laser pointer, on this one, we're going to take this whole chunk to the 1/3. So that means we have an index of 3. And my 1/8 x squared are both raised to the first power. Do we write an exponent usually when there's a 1? No. Because it doesn't do anything. It's just busy. Can we simplify either of these at all? Can't simplify the cube root of 1/8? The 3 was this guy here, our index on the exponent. Even if I do the cube root of 8. What's the cube root of 8? 2. 1 half. Cube root of x squared. It's not pleasant. I just wanted us to look at that and kind of see it. That's our fully simplified version. If all we are asked to do is put it in radical form, this is sufficient. But this is fully simplified. So if we're asked to put it in radical form and simplify, make sure we simplify. You can put our cube root of 1/8 in the calculator. It'll give you a 1/2. It can do that. Okay. Let's try a little bit more, but now we're going in the other direction. We're going to write it in our exponential form. So what is my index on this left one? 2. If there's nothing written there, it's a 2. So if we want to write this in our exponential form, we're going to have x to what fraction? Which one?
3 halves.
3 halves. Our power is 3. It is currently on top. It stays on top. And our index is 2. And yes, we could actually absolutely simplify it to be x times x to the 1/2. Or 1 and 1/2.
It's always 2. It's blank.
If it's blank, it is always 2. Yes. If there is no index written there, it is always going to default to 2 because if there's no index, they're intending it to be a square root. Let's do the right one. Whenever we have chunk, treat it as a chunk to start. So I'm going to have my chunk, my y to the 9th, x to the 7th, is going to get raised to what power? What's our fraction going to be?
1/3.
Yes. The combined group has a power of 1. So we're going to have our exponent of 1 over our index, which is 3. What's up?
Which one is the combined?
Oh, saying this group doesn't have an exponent on the outside, so it's kind of got a default of 1, since I'm looking at them as a group. But I don't really want to have them as a group. What do we do with powers when I'm got them over something being multiplied? We did it in Algebra 1, but I know it's been a hot minute.
We add the power.
That's if we multiply the bases, we add them. But if we raise them to a power, it feels like distribution. Powers over powers, we multiply. So I could write this as y to the 9 times 1/3, which is 9/3, which I'll get there, yeah. Or x to the 7/3. These y's really help us see why this fractional index is helpful. Because what does 9/3 simplify down to be? Just a 3. So this becomes y cubed x to the 7/3. It's still icky, but we're going to leave that one there. We could simplify the x's a little bit more and put it as a mixed number, but honestly, I mostly wanted us to see that 9/3 situation. We are, for the most part, going to simplify when it's in radical form, but there are times when the fractional index is helpful for that. We're going to use fractions for our exponents mostly when evaluating numbers. But that's going to be, one of those things we deal with. Okay. Questions on these one, or on these ones? Because like I said, we're going to use fractional indexes on our letters a bit. We're going to use them a lot more on numbers.
Ew.
Ew. I know. It's okay. We can do this. We can't, because what we're going to do is we're going to write it as a radical. Because I want to practice the switching back and forth. And we're going to evaluate it. I'll show you how to do it in a calculator.
Couldn't we just input it into the calculator like that?
Yes, but I want to practice the switching as well.
No, like in both forms.
Yes. So we've got 8 to the 4/3. If I want to write this as radical form, what is my power? 4. Power's on the top. What's my index? 3. So this would be what kind of root? The cube root of 8 to the 4th, which is an icky and unpleasant number. Ew. So to evaluate this, to figure out what number this is, we're going to go to our calculator. And we can do this in either form. I can take my 8 and raise it to the power. There's a button here that means to raise to any power I want. That's this little up arrow over here. It's called a caret. That puts me up into the exponent. Well, if we're in our fraction notation, our exponential notation, I can put in the fraction up there and put in my 4/3. I can put it as a fractional exponent just like that. And hit enter, and we get 16. You can also go, just like we did yesterday, our 3 as our index, cube root of 8 to the 4th, and write it that way. You could do our cube root of 8 and then raise it to the 4th. There's lots of different ways to do it. You can get the same answer. I could do the,
I don't know why I just clicked the clear button.
cube, trying to do a thing. There we go. Cube root of 8 to the 4th. I could do it in that order and get the same thing. So it doesn't really matter which order the things are done. We're getting the same answer either way. So this evaluates down to be 16.
It finally came down to a whole number.
Same thing on the other one. Let's put this as our radical form. What is our power? Power. 2. And what is our index?
Negative.
It's going to be the 5. I was going to ask, which one should we put the negative with?
2.
The power. We're going to take that negative with the power. Because a negative power we've seen before. I can't do it like a negative root. That's just icky. So our index is going to be 5. Our index will always be a positive number. And then we have our 32 to the negative 2. What does a negative exponent do again? Do you remember?
Makes it negative.
Does not make it negative. It is. It will be positive. It makes it a fraction.
Yeah.
So when we type this in the calculator and get a fraction answer, that's okay. Because this is the same thing as 1 over the 5th root of 32 squared. That's what the negative exponent does. So it's going to pull up some old exponent laws for us to remember. And again, I could put this in my calculator in absolutely any of these notations. But honestly, I think the fraction one is the easier one. We're going to do our 32.
I forgot the 2 on
Raise it to the power. Fraction. And I'm going to put my negative 2 over 5. If you put 2 over negative 5, it'll still do the same thing. If you put the negative out in front, it'll still do the same thing.
Oh, you're setting it up like that. Okay.
Oop, oop, wrong button. I was just say I could put it there. Totally fine. Out in front. Boop.
I like how it counts how many times you've used the button instead of just putting
Well,
it
it's so that if you were following along and you're trying to do exactly what I was doing, you could do this.
So does the one not count for everything?
The one, I was like, the one, no matter if we do square roots or anything to 1, 1 is, square root of 1 is 1, fourth root of 1 is 1, 1 to the 5th is 1. It doesn't change anything. So we are still doing it to the 1, but 1 doesn't ever change.
When did you put it under 1?
When we took it out of the negative exponent,
Oh, so to take it out of the negative, you put it under 1?
the negative exponent makes it be a fraction.
So when you change it to positive, you put the 1 over?
Yes.
Wow.
And then to get from any of these down here, we go through the calculator.
So I could really just say, I could really just remove the negative and just continue with my problem since the 1 doesn't do nothing.
As long as you put it then in the denominator. The negative makes it be the bottom of a fraction.
Okay.
That's what that does. Okay, so it's going to pull up some old exponent laws. I wonder if it might help to remember some of those exponent laws. This is our last bit. Remembering some exponent laws. Oh, snap. I wonder if that helps. Ah!
Ew.
All right. You learned these in Algebra 2. Or Algebra 1. I'm in Algebra 2 right now. Algebra 1. Spent a whole chapter on them in Algebra 1. So, we've kind of talked about a couple of them. When we multiply the bases, that's what this left one is. So we are multiply bases. What are we going to do with these exponents? Means we add the exponents. So this can become x to the power of, and I need to add them, 2/3 plus 1/6. How could I do 2/3 plus 1/6?
Add straight across.
We can't add straight across. I can multiply straight across.
Greatest common factor.
3 can
Mm-hmm.
multiply to 6.
Is that you're headed the right direction? Is that because we're either needing common denominators or to type in the calculator. Those are the ways to do it. So we need common denominator. So 2/3, I could multiply up to half of a denominator of 6. So we could do, I'm gonna show you. Just taking our exponents over here. To write this as 4/6 plus 1/6. So this is going to be x to what power? 5/6. You can also do in the calculator, just for those of us that hate fractions. 2/3 plus 1/6. The yellow calculators have some skill, as long as we type things in carefully.
I got it.
This middle one we kind of talked about. What does our negative exponent do? Flips it. Does anyone remember the name for when it flips like that?
No.
Starts with an R. What's up? Oh, we took this thing, reciprocal, that was the word I was looking for. We took this one, the green one here, and we multiplied it by 2. 2 on the top, 2 on the bottom. So 2 times 2 is 4, 2 times 2 is 6. So a negative exponent makes the reciprocal. That's our flip. So just getting rid of the negative in the exponent would give me 1 over y to the 2/3.
And that would be our, like, basically.
Yeah, it's
Final
simplified there.
answer.
It's simplified there.
Okay.
I was like, if we want to put it into our radical form, we could then do that. Be our cube root of y squared. We could do all those things.
What does that word say? I used to use it.
Flip. I will rewrite the P so that it actually looks like the little letter P. There we go. A little better. And then the last one, you can do this one in a couple of ways. It's kind of combining the ideas together. You can either deal with the negative and then have a fraction of a fraction. Kind of icky. Or we can treat this like the first one, where we add our exponents when we're multiplying the bases. So we can, I will, honestly, I'm going to show you both. So if we go option A, which is do exactly like we did at the beginning, this would be our z to the negative 1/3 plus 3/4. Multiplying the bases means we add our exponents. What is negative 1/3 plus 3/4? Mm-hmm. 5/12. Or we could deal with that negative exponent to make this be fractiony grossness, which is doable. Our z to the 3/4, which is positive, so it stays on top. Our z to the 1/3. If we set it up as fraction of fraction, when we are multiplying bases, we add them together. So if we are dividing our two exponential pieces, what are we going to do with those exponents?
Subtract.
Subtract. So this would be the same thing as 3/4 minus 1/3, which will give us what? I'll just write it down.
I'll say 5.
Mm-hmm. So it gets us to the exact exponent. Got an n. There we go. Exponents. So either way, we get down to the 5/12. This is another one of those times when we have a bunch of options on which way to go through it. So you can go either direction. We get to the same answer. Honestly, I think it's easier to deal with adding the exponents than it is to subtract, but I know some people really, really, really hate the negative exponents. Valid. Okay. Questions on these? And, okay. So, I'm just going to point out my very subtle bright yellow sign here. That's directly next to where I stand, so hopefully people notice it. Last day for late homework, December the 13th. Non-negotiable. It is in fact Taylor's birthday. But it's also the Friday before finals, which was honestly the more important piece, because I refuse to have people turn things in at finals, because I already have way too much things to do on that Friday when y'all ain't here.